Hi everyone, welcome to chapter 15, which basically deals with instrumental variables and estimation of a two-stage least square. So I'm just going to go into this. So instrumental variable and two-stage least square basically deals with the problem of endogeneity. In general, the problem of endogeneity basically is where you have a covariance or a correlation between the explanatory variables and the error term, and so that's why that's basically what it means. And so when there's that relationship, when there's that correlation between the explanatory variable and the error term, it will lead to a problem of endogeneity. You can find it in term especially a system of equation when you're dealing with variables that are determined within the model, especially if you have, say for example, variables like interest rate, which is determined both in the money market and the goods market. From the basic Keynesian model, or when you're talking about demand and supply, where you have quantity and prices being determined in both equations. So such a situation will actually lead to a problem for endogeneity. All right, so now one way of dealing with this problem is by actually estimating the model, which is referred to as the instrumental variable method. And this method is actually well known to be dealing with this problem of endogeneity. So let us look at how does this work. Let us look at this equation. Now let us assume that we have this wage equation where we have wage as a function of education. If we want to determine how education leads to wage, or whether education does have an impact on the remuneration of a person. Now remember that the error tables that affects the model. So now let us say we have this variable ability. Of course, now we have to look at this that fit the definition of an instrumental variable. First of all, an instrumental variable must not appear in the regression. Okay, that's fine. It must be highly correlated with the endogenous variable, which is basically education in this case, and then it must also be uncorrelated with the error term. Okay, so once a variable fulfills those criteria, then it can be considered as an instrumental variable. Is okay. Now let us obviously, under normal circumstances, if we have a situation whereby um, if we have a model like this where y is our dependent variable and xi is our independent variable, and we assume that xi and mu I are not correlated, such that the covariance between xi and mu I is equal to 0, then it basically then means that we can actually estimate our model using the OLS. But now let us go further. So this is basically, so in other words, we can only apply the OLS when there is exogeneity. So exogeneity exists when the covariance between the explanatory variable and the error term is equal to 0. If it's not equal to 0, then it's no longer exogeneity. Okay, now let us move further. Now, so we can actually prove this to say this relationship basically exhibit exogeneity. So, and if we are saying it's equal to 0, so we are basically saying xi is equal to, the covariance between xi and mu I is represented by this, because if I take you back to that equation, so if you make mu I the subject of the formula, then on the other side you'll have yi minus beta o minus beta 1 xi. So that's why in this equation you have that. So this is basically just a long expression of what mu I stand for. So it will then be equal to the covariance between xi yi minus beta 1, the variance of xi. So let us make beta 1 the subject of the formula, because beta 1 is a coefficient of interest, which has to be estimated because it's a coefficient of the explanatory variables. So if we divide both sides by variance so that we can have beta 1 as a subject of the formula, we will then have b1 is equal to covariance of xi yi over variance xi. So now if this is basically if this is true for the population, then it follows that even for the sample, which is basically where these estimates are coming from, that's why you have beta bar, covariance bar. This is from the estimates from the sample. It will then also follow that if it's true for the population, it will also then be true for the estimated value, because we are basically saying the estimate value tend to move closer to the actual value. Now we say for as long as you have this covariance or this type of relationship, then it means that there is exogeneity. For as long as there's no correlation between the explanatory variable and the error term at the same time, as well as if the so then basically you will have that exogeneity. So, and this will only hold as long as the data are such that sample variances and covariances converge to their theoretical counterpart. It basically means that as the number of observation moves tends to equal to 1, in other words, when you are applying the law of large numbers, okay, this you must have come across either econometrics 3 or econometrics 2 or even in statistics, where the law of large number is being applied. Then we tend to say OLS will basically be consistent if and only if exogeneity holds. So for as long as there is no covariance between explanatory variable and the error term, then there is exogeneity, and you can basically estimate using the OLS. Now, let us assume that there exists some instrumental variable. Okay. Now, let us name that instrumental variable zi. So we replace, remember that in the previous equation we had xi. So now if we have zi, which represents the endogenous variable, like in the wage equation we have education, because education has to be determined within the model, then we are then basically saying, so if there is no relationship between the endogenous variable and the error term, then that would still then it's still fine. In other words, the instrumental variable has no relation, or it's uncorrelated with the error term. But if there is a if there is a covariance now between the other explanatory variable, which is supposed to be the exogenous, with the error term, then it actually then means that there is going to be a problem for endogeneity. Why? If we have just to follow the same principle to derive the consistency, because the consistency, like what we did here, this consistency, because what we've shown here is that for as long as there's exogeneity with no relationship between, no covariance between the explanatory variable and the error term, we will have OLS, and it will be consistent and unbiased. So now in this case, we can then prove that. So yes, if we follow the same procedure and we want to find out what will be one, now in this case we'll have B1. Of course, here what you have is Z1 instead of x x x x instead of xi, sorry. So you actually then have that beta 1 will be expressed by that and will be expressed by that. But now what would happen is that, now of course what we can see here is that from this equation we can actually see that what then is likely to happen is that, remember that the instrumental variable in this case is now correlated with the explanatory variable. So the fact that the explanatory variable is correlated with the endogenous variable, and also the fact that the explanatory variable is correlated with the error term, then that creates the problem of endogeneity, because remember that the endogenous variable can also be part of the other explanatory variables, and if there's such a problem, then, or if there's such a relationship, then it will actually lead to the problem of endogeneity. Okay, so that's basically where this is all coming from. Okay, so let us just take one example. Say, for example, let us take, if we are looking at this wage equation as a function of education, and let us say now education is our endogenous variable, and suppose we want to use, for example, the father education of the father as an instrumental variable to sort of neutralize the problem of this to get rid of the problem of endogeneity. So we have to ask we have to evaluate that instrumental variables in terms of three criteria. First of all, okay, yes, it does not appear as a regressor in that model, in the wage equation model. Secondly, but now, okay, is it significantly correlated with education? It could be, because we know usually if your father is educated, in most cases their kids are likely to follow suit, or there's likely to be that relationship. Then lastly, is it correlated with the error term? Now we are saying if it's correlated with the error term, we will have that problem, okay? But if it's not correlated with the error term, we won't have that problem. So now what happens is that because if it's correlated with the error term, of course, it is likely to be correlated with the error term, because we know that the further this variable, if we put it in the model, it will still have an influence on the it will have an influence on the education of the child because there is some certain relationship, and so because of that, you are likely to have an imprecise estimation of this variable, which is education, which is the endogenous variable, because of the relationship between the father's education and the error term, because the father's education is supposed to be part of the error term, because the error term is supposed to capture any other variable that is likely to affect the model, and so therefore it actually it does not really qualify or fulfill the mandate of it being instrumental variable. But then again, it might qualify because it depends on how strongly it is. Is it strongly endogenous or weakly exogenous or weakly endogenous, whatever the case is? So, but at least you understand the principle that it does not really qualify because the father of education does definitely, it's definitely part of the error term. It's correlated with error term because it's captured there so that it doesn't affect the wage equation of the child. Okay, so obviously for this type of studies are mostly, or this type of models are used in economics of education, and they also have other determinants such as or instrumental variables such as the number of siblings. And here these are just criteria that we are evaluating whether it fits, or college proximity when 18 years old, or month on the birth. So what we are trying to demonstrate, it's very difficult to get a very good instrumental variable. It's very, very rare, and that's why that's basically the one of the downfall of the instrumental variable approach, and that's actually why most people, they would rather resort to the two-stage least square, and we will actually um, get to that in a bit. So what we had there could actually be an example of a poor instrumental variables, because if you have a poor instrumental variable, then it would then actually indicate that the variable is not, if the, for example, if it will definitely bring in some inconsistency, and so for that um, um, uh, you will have a problem in terms of your estimation. So what you're trying to say is that instrumental variable might be much more inconsistent than OLS if the instrumental variable is not completely exogenous and only weakly related to X. For example, in our example here, if the father's education is weakly related to the education of the child, and um, it then actually indicates that you know this variable is not even is not even completely exogenous, and so that will then introduce the problem of endogeneity, and so that's why sometimes it's rather best to use the OLS estimation as opposed to the instrumental variables, because instrumental variables might actually be worse. Okay. um, And so that's why we can then say the instrumental variable, the condition that it should fulfill is that it must not appear in the regression equation, it must not be correlated with the error term, it must and it must be partially correlated with the endogenous explanatory variable. But now we have actually seen that if it's related to the endogenous explanatory variable, and that endogenous explanatory variable is or does have and the explanatory variable has a correlation with the error term, then you have a problem of endogeneity. So for as long as the two of them are related, and so that's why it's really not a popular method to use because of its difficultiness in terms of finding endogenous variable. And so we can only use the instrumental variable method when the exogeneity condition is fulfilled, when it's fulfilled. And that end the first part of this lecture.